Welcome back to 15.2. We have been doing dot plots and line plots. And now let's do an example. So researchers recorded the number of times lab rats completed a maze in 30 minutes. The table shows the data for 12 rats. Make a dot plot of the data. So for a dot plot, we start with our x-axis here, and we want to put the number. So what's our lowest number? I'm not going to necessarily start at 0, right? What's my lowest number that I've got here? My lowest number, it looks like, is 10. So I'll start at 10, and I'm going to go by even intervals. I'm not going to skip just because, so I'm not going to go 11, and then I do have a 12, 13, 14, 15. If one of these numbers weren't there, I would still go in order because it's important to show when there is no data for, there are no dots for that number. But we've got something for everybody. So 13, 11, 15, 14, 14, 11, 10, 13, 12, 13, 11, 10. And try your best to keep them along the same line. So if you see here, they're kind of all along the same line. 2, so it's easier to compare. Because if we did something like, this was 1 and this was 1, that would look like they weren't the same, or this was 2 and that was 2. So you want to try to keep your dots the same size and kind of in line with each other. And that's our dot plot. We might say maze completions, just to kind of make sure we have a title. A doctor asked 15 people how many hours they spend exercising each week. The dot plot displays the data. What do any clusters and gaps in the dot plot tell you about the exercise habits? Well, I see a strong cluster over here at 1, and then over here 8 and 9. So what does it tell me? So we're talking about hours exercising per week. So it tells me that most people exercise either less than 2 hours a week or more than 7 hours, right? That's what that tells me. And see how they don't have any data there, but it would be misleading if we did this. See how I'm skipping numbers? I don't know how many are there, but it would be misleading if we did this because it would look like people exercise every day of the week or people exercise every hour. There's no gaps in clusters. So you want to make sure that you're putting those spaces when you don't have the data. So go ahead and complete these 2 U tries and then press play when you're ready to see the solution. And there we go. Whoop, and there's my dog. Okay, we'll give this a try. So next up is histogram. A histogram is a bar graph for which the categories are individual numbers or equal length intervals of numbers. So equal length, so there's 9 in between each of these. And just as we can think of fusing pictures and a pictograph to make a bar graph, we can think of fusing dots and a dot plot to make a histogram. So a couple of things. Histograms touch. Okay, there are no spaces between. All right? That's what makes them, that and the intervals make them different than bar graphs. Bar graphs are categorical and histograms are numerical. Histograms allow for a little more flexibility than dot plots. In histograms, the height of a bar can refer either to the number of pieces of data in that category or a percentage. So on a data plot, we always have just the number of. We're not going to be able to display percentages over here, but with histograms, we can display percentages. All right. Let's look at an example here. So the histogram groups recent visitors to a library by their ages. From which age group were there the most visitors? All right. So the most in a histogram here, I'm going to say this guy right here. And what's that interval? It relates from 60 to 70 years old. Okay, now let's make a histogram. The table shows how many times each of 10 students walked a dog last month. Make a histogram of the data. We're going to think about other histograms for this data that use wider intervals and describe how the shapes of the histograms change. Okay, so first let's decide our intervals. So we want our intervals that we want here, and we're going to tally up in between the intervals. So our smallest number is 3 and our biggest number is 26. So maybe we want to go like we've got 47. So we definitely want to go from 0 to 50. And so maybe we want to do intervals of 10. So we might say like 0 to 9, 10 to 19. And again, 0 to 9 has 9. This has 9, 20 to 29, 30 to 39, 40 to 49, and 50 to 59. And we actually probably don't even need that 51 because we only go. So 3 goes in this tally, 22 goes in this tally, 47 goes here, 16 here, 26 here, 33 here, 37 here, 4 here, 31, and 4 again. So now when we construct these, okay, we're going to put our frequency over here, our tallies, and our intervals. So we go from 0, 9, and I'm just going to put 10 here, 10, 20, 30, 40, 50. So, and then we don't have much. We go from 3. So let's say 1, 2, 3, 4. So from 0 to 9, 10-ish here, we've got 3 tallies. From 10 to 19, we have 1 tally. From 20 to 29, we've got 2 tallies. From 30 to 39, we've got 3 tallies. From 40 to 49, we've got 1. And then these would be dog walks. So there's our histogram. What would it look like if we did a wider interval? So, okay, what about if we did intervals that kind of had more space in them? So instead of 0 to 9, maybe we went 0 to 19 and 20 to 39 and 40 to 59. Those are wider intervals. They cover more space. So from 0 to 19 is actually going to be 1, 2, 3, 4. From 20 to 39 is 1, 2, 3, 4, 5. And 40 to 59 is just going to be 1. So just at a quick glance here, if we did 20, 40, 60, 2, 3, 4, 5. 0 to 19 is going to be 4. 20 to 40 is going to be 5. And this is going to be 1. So we can't really see the shape of what's going on here. It kind of mushes all our data together. So that's why we don't want to have super wide intervals. Go ahead and give this a try. Press play when you're ready to see the solution. And there we go. Now, a stem and leaf plot or a stem plot can be used to quickly organize numerical data. It looks like a horizontal dot plot. So if I was to take this and turn it on its side, you could think of it as a dot plot, but instead of the dots, 1, 2, 3, we're going to actually put the numbers. Okay, so it's the same idea as a dot plot. It's just looks a little different and it has the numbers. Ooh, can't get it straight now. All right, so the stem is over here. These are our stem, and then here are our leaves. All right, and so the third row, let's look at the third row here. What this means, and this is a terrible key because it's got the same number. Like I would use any other key. Like let's make a key starting with the 4. The 4 and the 3 means 43. The 5 and the 7 means 57. Okay, so for example, in the third row, this row here, 2609, this means data 22, 26, 20, and 29. So that's how you read these. And sometimes the key will tell you that they're in the thousands or the millions. But we always want to make sure we only have 1 digit in the leaves. Okay, you can have more digits in the stem. Line graphs are another type of graph for numerical data. And sometimes they're just a graph of a function. So a line graph is which adjacent data points are connected by a line, and they're appropriate only for displaying continuously varying data. So data over a period of time. So here we've got the average math scores of 9-year-old children, and we can see that they've been slowly increasing. And so if we read this, we can see that we're looking at years over here and we're looking at scores over here. And so we can say, all right, in about 1999, the score was about 230, but in 2012, the score was maybe about 240. And so because of the way it's graphed, we can make sense of data as it changes over time. They're not appropriate for data in categories or that data that doesn't vary continuously. So for example, it would not be appropriate to use a line graph to display data on state populations. This is an inappropriate line graph, okay, because it looks like what it's saying is that the population decreases when we get to Wyoming. But that's not true. These are separate things and we don't want to compare them. A line graph assumes a continuous variation, but these have nothing to do with each other. If we wanted to look at population, maybe we would do Wyoming as its own, and then we would say different years, and then we could see how things are changing. Go ahead and give these two problems a try. So this is 1 and 2, and then press play when you're ready to see the solution. And there we go. And when we come back, we'll explore some more data displays.